You ready for another kit build? I think this time I am going to do, this one here, which is the fidget spinner kit that I got in a mailbag a few weeks ago. It's 100% surface mount and should be fairly straightforward to put together. There's a little bit of mechanical stuff to deal with as well, but it should be fun, even if fidget spinners are kind of passé. Apparently, according to the listing, it displays patterns on these LEDs here, and while they're spinning, it presents them as persistence of vision displays, so displays patterns and stuff. First, I have some important business to take care of. Preparing my supplies. And tonight's tinkerage is accompanied by Black Lager from The Goodwill. The Goodwill is a music venue, among other things, in Winnipeg, and they have been around for several years. Unfortunately, they are at the risk of closing at the moment. But this beer isn't a fundraiser for them. This beer is a fundraiser that they are running for the Main Street Project, which is a nonprofit agency in Winnipeg that provides services to people that are living on the street, people with addictions. They also run a food bank and supply essentials to people that, like I said, are living on the streets or are having a hard times. And the beer was made by our old friends Barnhammer, so you know it's a good one, and yes, I can confirm that it definitely is. So the first thing I'm going to need, I think, is a PCB holder. And I don't use this one very often. It's pretty good for surface mount boards, and it's kind of useless for any board that you have to flip back and forward. So I think I'm going to try it for this one, because this is 100% surface mount. So that's gripped it pretty solidly, even though it's a weird shaped board. So other than the PCB in the kit, we have some mechanical bits and pieces here. I'm just going to pop them out. I'll probably throw them back in the bag so that the little screws don't get lost, but we have 3 little battery holder pieces, some small screws, and then this little bearing here, which, is the spinner part of the fidget spinner. So we'll grab onto those. Oh, and what else is there? It's a little pushy button too. A really, really tiny push button. There's the body of the thing itself. These are 2 little buttons that go onto the bearing through the hole there, and let you do that. We'll leave that until later. Here's the components, all surface mount components. Let's see what we've got. We've got a bunch of 101 resistors, so that's 10 with 10, so 100 ohms. We got a couple of 103 resistors, so that's 10 plus 3 zeros, so 10k ohms. Got one lonely little capacitor, and these things are never marked, so I don't know exactly what that is. We've got one 14-pin IC, which doesn't appear to have any markings on it, though it's probably a microcontroller, and we won't be able to reprogram it anyway, so I guess it doesn't matter that much that we don't know what it is. I'm still curious, though. And then we have 3 packages of LEDs. No one package is enough to do the entire board. You need 11 for that. So I'm guessing that we'll select different colors and do 3, 3, and 4 or something like that. This one is probably blue because it's marked that way. Well, that one's got a stripe on it too. Maybe it's red. These ones are white. Could be. And that's it for the components in this kit. It's not a lot of components, but the hard part is just going to be soldering them all. So since this is a 100% surface mount board, I think I'm going to take the suggestion of somebody in the comments in one of the previous videos and use my soldering microscope. And I'm actually going to take the suggestion of a few other people too while I'm at it. I'm going to use some skinnier solder than I had been using, and I'm going to use some flux. Some people suggested that I should just go out and buy these things. I already have them. This is why I bought things ahead of time, so that I would have them when I need them. You didn't think I was hoarding this stuff just for no reason, did you? By getting the board under the microscope, that's going to make it a lot easier to see. The only problem is having a single screen to watch means that I don't have my binocular vision to use when I'm staring at the screen, so that might make it actually a bit more awkward for me. But with my small soldering iron tip, that should work pretty well. So I think I'm going to start off with resistors first, and they will go in these spots over here. Now, I'm not sure if, I'm not used to using extra flux with solder. This solder that I am using is fairly skinny and it doesn't have a lot of flux in it. Apparently it has a little bit of flux in it. And if you melt it, you can see that there is some flux, some smoke comes off it. So hopefully that will be enough, but everybody always says use more flux. So I will squirt a little bit onto here and just use that to hold down the component, I guess. Looks like the board is already tinned a little bit. Let's see what that does. As I said, I don't use extra flux all that often, so this is a learning experience for me. I don't know if I should be putting these all in first or just one at a time. Maybe I'll just try one at a time for now and see what happens. And again, this isn't going to be pretty because I'm not the steadiest at this stuff. Oh, it didn't work very well. Is it loose or is it stuck down? No, it's soldered down. Now this is really hard getting used to, working without my binocular vision in the microscope. It's there, it ain't pretty, but I'll put some solder on the other pad and it's on there. I don't like it. Let's try with the next one. I'm sure people are going to be laughing at me. If I was worried about that, I wouldn't be doing this online where everybody can see it. This is a learning experience for me, and I'm hoping that somebody can learn from my mistakes, if nothing else. That's less bad. Come on. There. Yeah, I think I am going to reflow those with hot air and see what happens before I move on to the rest of the board. Maybe something will happen, maybe nothing will happen. I don't know. Well, that's better, I think. Far from ideal, but better. Maybe I'll change my angle a bit and see if that does anything. Well, that's not ideal. I don't know if those tweezers got stuck with flux or... Seriously? What the hell is going on here? Don't let my fumbliness discourage you from giving this stuff a shot. And you don't need all this equipment. I've just acquired it over a period of time and I'm finding it somewhat useful to use. Again, it's a practice thing, right? So this next one, I'm going to go back to my old traditional method of tinning the pad first, then putting the component on. Again, this is all just learning. Yeah, that's in place, okay. And get in from the back side and just add a little bit there. Yeah, that's pretty ugly. Fortunately, there's a bunch more to go. I think for now, I'm just going to carry on down the row. You've seen me struggle. I'm going to move this camera here out of the way because it's kind of in my face. And we'll see what I can do. I'll come back afterwards. There, that is all the resistors. And I think you can see as I got further along, I got, well, slightly better at it. I think 10 is probably one of the nicest ones. 8's pretty good. Yeah, the first few are pretty rough. But I have improved, so that's something. Now then, I think before I get too carried away here, I want to figure out which side of these LEDs is positive and which is negative on the board, because there is no schematic and it doesn't say anything on the board itself. So this is these tabs here are the positive side of the batteries on the other side, and that goes to the common of the resistors, and then the resistors come over here, I think. Yeah, they do. So the right side, or this side here, is the positive side, the anode of the LEDs. It means this side switches through the microcontroller over here to ground. Before I do those, I've got a couple of other components down here to put in. Over beside the microcontroller, we have R12 and C1. And those two look like they're tied together there and tied to that pin. So I'm just going to put one of my probes onto the positive again, and I'm going to guess this capacitor is across the positive, which it is. That's the positive there. And if I put my probe on the underside of the board on the negative battery terminal, the other side of the capacitor is that. So that's just a decoupling capacitor. Also, this resistor R12 ties to the high side, and then I think you can see a trace there. It ties to that pin, and that pin goes through the board. And where does that go? That's my through hole there. That goes to the switch. Okay, so that makes sense for this R12 to be a pull-up resistor if the push button switching to the ground. So that pull-up resistor is likely going to be the 10K that we saw, and not going to be another one of these 100 ohm resistors, right? That makes sense. So let's throw that in next. Actually, we can throw both the capacitor and the resistor in. I think it might not be a bad idea to put them both in at the same time as well. And since this method was working reasonably well for me, I'm just going to stick with it. Put a big gob of flux on there. Not quite a Rossmann amount, but we're approaching it. I'll just get in there and tin that pad. And which one should I tin on this one? Let's tin that one. I don't know if that's the right choice or not. We'll find out shortly. Getting the components out of their packaging is a bit of a trick that I haven't quite figured out the most elegant way to do it yet. These packages are meant to be machine fed, and so the machine would pull them out. They're not really designed for human dexterity, so that's my excuse. Did that take? Yep, that took. Okay. And just get the solder in from the other side. I guess I will go for the LEDs next. As I said, the right-hand side of this, where the D marking is, that is the positive side of these LEDs. So we'll start from here, and referring back to the website, the outer three are blue, so I will stick with that. Now that I'm going to assume that these are the blue LEDs because they've got a blue stripe on the package. But I guess we don't really have to assume that. I can actually test them. I'll put my meter into diode test mode. And using the little measuring tweezers here, if I can get onto them, you can see that it's going blue in the test mode. This side of the tweezers is the negative side, so the other side is the positive side. And we'll just set it down onto the board in that orientation. Also, it looks like we have an orientation marker on there. that's all the LEDs. So now all there is left on this side of the board to solder is the chip. We'll just repeat the same method as before because that seems to be working for me. Throw down a bit of flux on here. I suppose at one point in the future here I should figure out the best way to clean these boards. I haven't been doing that previously because most of the time I just really don't care that much. But if this thing is going to be for show, then maybe I want to. Yeah, there's still no lettering on this thing, even out of the package, can't see it. Well, then I guess it doesn't really matter all that much. So we have a notch here indicating that pin 1 is this one here. And there's a dot indicating pin 1 on the actual chip. So that orients that way. Set it down over there just for a second while I tune up the one corner pad on the board. It should, hopefully, hold him in place. Get that nicely aligned. Reflow that solder onto the leg. It wasn't a lot, but it is holding it there. Now we'll pick another pin. Let's pick pin 1 and solder that down. Maybe a little bit more solder. Come on. Why are you not melting? I hate how long I have to linger to get this cheap crap solder to melt on there. But I think it's done it. Yeah, we're solidly on there. So let's pick one on the other side here. There, that's flowed in there nicely. Okay, and then I'll just go all the way around, soldering them down to make the good electrical connections that we need. And as I mentioned before, I'm going to bounce around so that I don't linger heat in any one area of the chip too long, so they don't cause any damage. I know I am not doing the best job here, but do what you can to minimize damage. So now the only thing left to do is on the other side. Oh, there's that push button. I forgot about that. I do have a bit more surface mount soldering to do. But then I can get to putting the battery holders on and see if this thing actually works. Do I need flux for a push button? Yeah, probably. It'll at least mechanically hold it down. As I have been complaining the whole time, this stuff is a bit gloopy and sticky, so we will just use that to our advantage here. Tuning up a corner pad, as always, nothing changes here. So far I still don't have my depth perception, and I keep poking the solder either too high or too low for what I'm working on. Okay, and then just get the other corners as always. So now I have the battery holders to put on. They go in like this. There's these two little tangs back here that just sit on the board and back the battery up, and there's a couple of silkscreen markings that match up with them over there. Those just squeeze into the holes, and then we solder from the other side. I think I'm going to switch to my slightly bigger solder, which has more flux in it for doing these. Also, I no longer need the microscope. But maybe I need a bigger soldering tip. I'm heating up this whole big chunk of metal. I don't know, we'll see. All right, there we go. Oh, that's hot. There we go. Aside from mechanical stuff, that is done. Let's throw some batteries in it and see if it actually does anything before we start putting the plastic bits on. Now this thing says it wants 1620 cells. I couldn't find 1620. I found 1616, which are only slightly smaller in the diameter. The same thickness. They're all 3-volt lithium, so I think that should work. And These batteries are all three in parallel on here, so realistically I only need to put one in to get it to run. The reason for three of them is, of course, to make it mechanically balanced. So let's just slide one of those guys in and push the button. Damn it, I got one of the LEDs wrong. All things considered, that's not bad for my level of skill in soldering surface mount. What did I say? It was D5, right? Hey, you can totally see that I've got D5 in there backwards if you just look at the shape of the guts of the LED. Okay, so that should be a relatively easy... Oh shit, no, I've got to use the heat gun to pull that out, don't I? Ooh. That's going to be a challenge. Toss in the battery, push the button. Hey, they're all working. Awesome. It looks like it's doing patterns, or trying to do patterns. So I think I should throw the mechanical bits together and try this thing and see if we can get our persistence of vision stuff working. Now then, with the battery pressed in there, there's a little stud in the case that matches up with the push button. I'll drop that in that way. And then put, does this have a specific way it goes? Oh, I guess that way would be good. Okay. And let's put the little grabber bits on there. And I guess we just test it. Push the button. I've got lights. And spinning it. I can see patterns. You can't see patterns. Aw. How am I going to demonstrate this persistence of vision thing with the camera? I'm going to spend some time trying to figure out how to make this thing show up on camera, but it does in fact work, which surprises me. And second time, I guess, really. First try I had that D5 in backwards, but that's not too bad. Yeah, outside your comfort zone. Try different things and practice different skills. That's kind of what this month of kit builds is about, is just practicing skills, having fun, chilling out, relaxing, playing with some basic and not so basic circuits. I am enjoying this. I hope you guys are too. Thanks for watching. Questions and comments, as usual, down below in the comment section. I'll talk to you later.